great engineering projects that stand upon the landscape have evoked immediate community acceptance. Up until the 1960s, the public took a tolerant interest in engineering structures springing up all throughout the country under the boom of post-war development. But public disquiet about what engineering projects were capable of doing to the landscape really came to the fore with the proposals for the Aotearoa power scheme and the threat of this.
An overseas consultant had recommended a dam at the head of the Aotearoa Rapids that would leave the watercourse dry and empty. Public pressure was aroused by this possibility to the extent that the proposal was modified. The compromise here is not entirely satisfactory. From a tourist's point of view, if you time your visit, you will see the rapids as the forces of nature intended them. The power scheme has been reduced from the 24-hour operation originally planned, and loss of income from power production has been balanced against scenic values. Further public controversy was stimulated in 1964 by the disclosure of plans for the Tongariro power project. This scheme was to capture by canals and tunnels the water in rivers flowing off the volcanic plateau, using these for electricity generation. Technically, the scheme made good sense. It was to collect the headwaters of several major river systems and feed them through 2 new power stations and then through Lake Taupo to the existing 8 stations down the Waikato. In this case, it was one of New Zealand's most notable artists who alerted the public, with his accusation of the engineers being Philistines with bulldozers. Peter McIntyre called for hands-off Tongariro National Park.
But the scheme that turned the tide of public concern into a torrent of criticism was another power project. It was the largest hydro scheme in New Zealand's history, here deep in the south of the country in Fiordland National Park. The proposal was to raise Lake Manapuri 11 metres to the roof of the travel centre over there. It was this that brought a new term into prominence in the New Zealand vocabulary: environmentalist.
Can you visualise what would happen to the shoreline if the lake was raised 11 metres? These islands, they'd disappear for a start. And what about the trees? This is the scene 24 kilometres away over the Hunter Mountains at Lake Monowai. Bit of a mess, isn't it? The Southland Power Board built a local power scheme here in 1925. This is what happened when the water level rose. What bothered environmentally concerned citizens of the 60s was how to avoid this sort of shoreline at Manapuri. Pragmatic engineers proposed a massive foreshore forest clearing operation, but it was feared that this would damage the fragile foreshore ecology beyond repair. Environmentalists argued that if power had to be generated here, it must be done within the natural range of lake levels, and that is what finally happened.
The Manapuri controversy became a turning point in the relationship between engineers and environmentalists. In a sense, each had come to understand the other's language. References to engineers as Philistines became history. But really, were engineers such an uncultured lot as the public had been led to believe?
The versatility of pioneer engineers also extended to the range of their cultural pursuits. Arthur Dobson was a talented musician as well as a surveyor, with interests in astronomy and horticulture. The builder of this early Otago Bridge, John Thompson, was a notable painter of watercolours.
Dobson and Thompson demonstrated qualities in both technical and cultural pursuits that seemed to typify engineers of those early days. The author of this book summed it up this way: an engineer? I'd grown up among engineers, and I could remember the engineers of the 20s very well indeed. Their open, shining intellects, their free and gentle humour, their agility and breadth of thought, the ease with which they shifted from one engineering field to another, and, for that matter, from technology to social concerns and art.
Those early engineers showed a sensitivity to the environment which somehow seemed to get lost through the boom period of the 1940s and 50s. So do engineers of today care about the environment? Does civil engineering, as the art of directing the great sources of powers in nature, give the engineer a license to ride roughshod over the environment? David Thom is a director of one of New Zealand's leading consulting engineering practices. Since the 1950s, he has been most active in promoting environmental sensitivity within the engineering profession.
Engineers' work is very visible, and working in the sensitive and beautiful New Zealand landscape, they really can't help but become aware of it. You can, in fact, see this in the history of some of the conservation engineers like Arthur Dudley Dobson and Arthur Mead of the Auckland area, and it's noticeable that particularly the engineers who are involved in water engineering in one form or another, where they just can't help but notice interactions between engineering and environment, are amongst the leaders. But you can also see it in the work which has been done by the Institution of Engineers, say, over the past 20 years, that engineers are very concerned.
The Institution of Professional Engineers some years ago created an environmental award. What was the background and reasons for this?
Well, fundamentally it's to encourage environmental thinking in engineering. The fundamental terms of the award are that the engineer, it will be evaluated on the basis of the demonstrated concern for the environmental factors in a particular work, and the manner in which the whole of the engineering and environmental problem has been resolved in that particular case.
An early winner of the institution's award was the Ministry of Works for this stretch of highway between Wairaki and Taupo. Careful design and landscaping blended this road with its natural surroundings, providing space for recreation and relaxation for the travelling public. Another environmental award winner was the railway deviation on the North Island main trunk near Taihape. Great care was taken with this section, and Ray Ryan is pleased with the way his engineers eased the new line through the landscape.
We had to consider three particular aspects. One, to minimise the impact on the community. Two, to preserve existing landscape. And three, to make sure the project blended in with the massive landscape that is here. With the community ones, we managed to route the railway around the back properties, back boundaries of properties, avoid the township, re-establish pastures quickly. With the preserving landscapes, we managed to be very careful with water runoffs, avoid large areas of bush. And with the aesthetics, you'll notice how the structures blend in with the massive landscapes that are there, minimising the impact on the water ecology aspects associated with the rivers beneath them.
The 1980s have seen additions to the list of environmental dilemmas. How do engineers enable a community to have its cake and eat it too? In the centre of New Zealand's major thermal areas lies a lake bedevilled by development. salts from thermal discharges, fertiliser from farmland, sewage effluent from the city, to which thousands of tourists contribute each year, all these things are killing the lake slowly, year by year. The problem here is nutrient enrichment of the waters of Lake Rotorua.
Here is the problem. Nutrient salts, particularly phosphates, fertilise algal and weed growth, which are gradually taking over the lake. The very asset that attracts people here is slowly being strangled by the waste produced from those same people. What can be done?
From this to this. Modern sewage treatment can produce what seems to be a clean effluent, but the phosphates in here are the problem. Advanced technology treatment systems are required to remove them. Maybe then, the effluent could be put elsewhere.
Engineers came up with what appeared to be the ideal solution for cleaning up Lake Rotorua. Pipe the effluent around the lake to the Kaituna River, only hours from the sea.
This simple and effective scheme overlooked an important community aspect. The waterways around Lake Rotorua are living entities to the local Maori people. Any form of sewage effluent would desecrate ancestral and spiritual values, spoil food and plant resources. An appeal to the Waitangi Tribunal prevented the pipeline discharging into this pool on the Kaituna River, and the scheme was abandoned.
This decision does not, however, condemn Lake Rotorua to continue accepting the phosphates in the effluent from here. There are other engineering options available. These, of course, can be quite expensive, but the Rotorua community is prepared to pay for environmental protection.
But it was not at Rotorua that the impact of engineering works on Maori cultural values first came to public attention. It was in Taranaki at Waitara, and the problem here was waste outfalls into the sea. Sandwiched between the coastline and Mount Egmont is a rich countryside. Fertile volcanic soils support lush dairy farms. But there are riches below too, below the land and the sea. This area is the energy centre of New Zealand, and this has spawned a host of energy-based industrial projects. The Motunui plant is a world first. A combination of overseas technology and New Zealand expertise has developed a special process that converts natural gas first to methanol, then to petrol. The environmental impact of a large-scale project like this can be enormous. So can the social impact on the surrounding community if things are not done properly. And here at Motunui there was an added factor. You cannot have all this industrial processing taking place without wastewater being produced. The plant's proximity to the coast made the sea a logical site for the disposal of liquid wastes, once they had been suitably treated.
Initially, the engineers proposed to construct a wastewater outfall through the rocky foreshore reefs into the offshore currents. But what was overlooked was the significance of those reefs as feeding and breeding grounds for the traditional seafood resources of the local Maori people.
It had seemed an easy solution. The Motunui plant uses large quantities of water in its operation, and the engineer who looks after the environmental requirements of this billion-dollar investment is Eleanor Trout. She takes up the story.
Essentially, if you go back to the development of this plant, the planning procedures actually allowed people to voice their concerns, and as the design developed on the waste treatment side and the community voiced their concerns, these were taken into account in the overall design of the effluent plant and the disposal site. We are certainly concerned about the Maori issues in the Taranaki area, and they have been taken into account, particularly in the area of where we dispose of our effluent. Originally we had a standalone outfall at Motunui, which the Maoris were not at all happy about, and now we discharge at a common outfall at Waitara, which they accept as our discharge point.
Foreign technology contributed to getting this plant underway, but dealing with the disposal of waste residues is a New Zealand problem. The flame of debate continues on as a satisfactory balance is sought between the country's energy projects and cultural values. This beacon is a central feature of Taranaki industrial development. Like an iceberg, the bulk of this structure lies below the surface of the sea, and this has produced an environmental impact in reverse. Marine scientist Dr. Brian Foster explains.
The engineers who were installing the platform, bringing it onto line, were concerned about the numbers of New Zealand green mussels that were growing on the platform itself, and the size that they were achieving. It seemed to them that they were rapidly exceeding the design allowances, and they wanted to know if they were going to exceed the design allowance and in what time interval. We were able to tell them on our knowledge of the growth rate of the New Zealand greenlet mussel that it would be very quick time, they would be in excess of the design allowance. We had to sample the marine life using company divers and saturation limits to plot the distribution of the mussels and other forms of marine growth on that platform. So we were able to tell them that within a year the design allowances based on the Northern Hemisphere mussel would be exceeded in New Zealand, and this required them to bring about cleaning procedures. Subsequent to that, we kept a watch on the platform for the growth of mussels and other marine life, and able to advise them whether it was going to reach dangerous proportions in terms of wave stress.
Pipelines are the key to energy use. Once laid below ground, you have an engineered energy network linking the Maui gas platform with places all over the North Island, underground and out of sight. From ground level, all appears to be hidden.
From the air, white markers cross the Taranaki landscape, plotting the path of these pipelines. They lead north and east to major cities and industries.
These pipelines have to be above ground. What they're carrying is so hot that these large expanding loops are vital to the safety of the line. Mount Egmont, now some 200 kilometres southwest of here, may be extinct for now, but here at the Wairaki geothermal field, on the edge of the central volcanic plateau, New Zealand has developed skills in harnessing volcano energy.
In using subterranean steam to produce electricity, New Zealand engineers have achieved world recognition. The steam, drawn from deep bores, must be dried out before it is used to drive turbines for power at this plant on the Waikato River. There are important environmental implications here as well. The residues from this steam scrubbing include geothermal salts, one of which is arsenic. At the moment, these go into the river, but now engineers are studying a solution that will inject these wastes back to where they came from, underground. At Auckland University, New Zealand has the world's only geothermal institute established for the postgraduate training of engineers from the many countries with geothermal resources. Next door to the Geothermal Institute, future engineers are being trained. At the end of a 4-year degree course, this final year class is studying the effects of engineering on the environment and society. It's an issue which also concerns senior members of the profession.
My belief is that we try to look at the problems that are created after they've occurred rather than foreseeing them before they happen. I think it's also essential that the public at large has an opportunity to participate and to have an input into these questions when a proposal is put up, so that one needs a means by which they formally can make their submissions one also needs that to be very probing, and one needs all the information that's relevant to be available, and that isn't always the case now.
Alan, what concern has the profession shown for social matters?
I think one can say that the profession as a whole has always shown concern for social matters, but as technology has become more all-pervasive, some of the effects are becoming very marked. And of course there is a group here in New Zealand called Engineers for Social Responsibility that set itself the particular concern to worry about social consequences of major engineering activity.
In the end, it's the community that must make the decisions on the options and choices it has in controlling technology. The irony is that those decisions will probably be based on information collated by that very same technology. Computers are central to the information age, an age in which engineers are being urged by some people to take a wider, more moral view. People like Professor Lloyd Gehring, one of the country's best-known theologians, are questioning not the technology, but how it is used.
Technology has multiplied in its capacity so much in recent years, and the potential is for a tremendous amount of good, but on the other hand, there's a potential for a tremendous amount of unfortunate evil arising from technology, if not wisely applied for the general good of all mankind.
And what criteria would you see as important in making decisions about the use of technology?
I think the engineering profession, like other disciplines, must be alert first of all to the moral issues that they are involving themselves in with everything in fact that they do. And because of that, they not only have to be sensitive to these, but have to be ready to learn from other disciplines and from people generally, so that everything they plan can be under some sort of overall moral control for the ultimate welfare of the whole human race. We can no longer think nationally as we once used to.
We began this series with a 19th century beacon, a lighthouse, one of the earliest civil engineering works in the development of this small country at the end of the world. We end it in the shadow of an unmistakably 20th century structure. Our isolation is over. The development of this society is no longer dominated by roads and railways. We may still see a continuing importance of civil engineering in building and utilising the country's resources, in providing links for energy projects, but it is the transmission of information via satellite and glass optic cable that will dictate our future directions. The question we all face is how wisely we can use those information signals from our modern beacons.